Good morning everyone, myself Paklanov. I'm currently pursuing my BTech education in FRIT College as a second year student in CSC department, and I am here to give video presentation on my topic recoverability in database management system. What is recoverability in database management system? Consistent state restoration, transaction persistence, data integrity and durability. Consistent state restoration. The ability of a database system to restore a consistent state after any failure, from system crashes to hardware malfunction. Transaction persistence. Ensure that all committed transactions persist permanently, while any uncommitted transactions are completely undone. Data integrity and durability. Critical for maintaining the highest level of data integrity and durability, safeguarding against data loss or corruption. Why recoverability is crucial. It prevents data loss and corruption. It maintains trust and reliability. Enables smooth service continuity. Prevents data loss and corruption. Crucial in avoiding irreversible data loss and corruption that can occur during system crashes, power outages, or transaction failures. Maintain trust and reliability. Build and sustain user trust by ensuring data is always available and accurate, fostering reliability for all business operations. Enable smooth service continuity. Facilitate a seamless continuation of services with minimal downtime, ensuring operations resume quickly after any disruption. Levels of recoverability in database management system. No undo logging. Only committed transactions are saved. Changes from uncommitted transactions are not undone, making recovery simpler but less robust. Undo logging allows the system to undo uncommitted transactions. However, there is a risk of logging some committed updates if not handled carefully. Redo logging enables the system to redo committed transactions, ensuring its durability even if the database fails before all changes are written. Undo redo logging provide full recovery capability by supporting but both undoing uncommitted changes and redoing committed ones, offering the highest consistency. Types of transaction schedule based on recoverability. Recoverable schedule. Transactions are structured so that transaction only commit after all other transactions depend on have also committed. Irrecoverable schedule. Occurs when a transaction commit after reading data that another uncommitted transaction has written, creating a risk of inconsistency if the latter fails. Cascading rollback. A situation where the failure and rollback of one transaction necessitates the rollback of other independent transactions that read its uncommitted data. Cascadeless schedule. A stricter schedule by transactions are only permitted to read data that has already been committed, thus preventing cascading rollback. Recoverable versus irrecoverable schedule. Recoverable example for recoverable schedule, as we know, safe data handling. In a recoverable schedule, if transaction T2 reads data from T1, T1 must commit its changes before T2 is allowed to commit. This sequence ensures that if T1 fails, T2 can also be rolled back without compromising data integrity. In recoverable schedule, which is high risk, an irrecoverable schedule arises when T2 reads uncommitted data from T1 and then commit its own changes before T1 commits. If T1 subsequently fails and rolls back, T2 committed changes are based on invalid data, leading to potential inconsistencies. Cascading rollback explained. Domino effect. When one transaction failure triggers the rollback of multiple other transactions that have read its uncommitted data, leading to its cascade. Resource waste. Causes significant waste of computational resources as work done by numerous transactions is undone, prolonging recovery time. Complex recovery complicates the recovery process, making it harder to restore the database to a consistent state efficiently. Cascadeless solution. Cascadeless schedules are designed to prevent this by enforcing the transactions only read data on once it has been fully committed, isolating failures. Technique to achieve recoverability. There are four types of technique where we can achieve recoverability. Transaction log, checkpointing, shadow painting, rollback and roll forward. Transaction log, detailed record of all database changes, enabling the system to undo partial transactions and redo committed ones during recovery. Checkpointing, periodic snapshots of the database state. These significantly reduce recovery time by limiting the portion of the transaction log that need to be replayed. Shadow paging, updates are performed on copies of data. The original data remains intact until the transaction commit. Then the shadow pages replace the original. Rollback and roll forward. Rollback undoes the incomplete transaction. Reverting changes. Roll forward reapplies the changes from committed transaction to restore the database to its most recent consistent state. Coming to the best practices for database recoverability. Regular and off-site backup. Implement a robust backup strategy including frequent backup stored securely off-site to protect against local disasters. Automated recovery process. Automate recovery script and procedures to minimize manual intervention and reduce the likelihood of human error during critical recovery operation. Frequent testing of recovery. Regularly test your recovery procedure in any simulated environment to ensure their effectiveness and to identify any potential weakness or bottleneck. Proper login and commit protocol. Configure transaction login and commit protocol meticulously to capture all memory information for accurate and efficient database recovery. Now coming to the conclusion, but last but not the least, recoverability is the backbone of reliable database management system. In the digital age, data is paramount. Database recoverability is not just a feature, it's the fundamental safeguard that ensures business continuity and preserves trust. Data consistency and durability guarantees that data remains consistent and durable even in the face of unexpected system failure. Business continuity protect business operations from disruption, ensuring quick restoration and minimal impact on services. Essential for DBS, a critical concept for every database administrator to understand and implement effectively for robust system. Thank you for giving this wonderful opportunity.